Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 2 of a 3-part series on trigonometric functions for mathematics grade 11, and that is the cosine graph. In part 1, we dealt with the sine graph, and in part 3, we're going to focus on the tangent graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 3 of this 3-part video series and any more videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at number 1, functions of the form y equals to a cos theta plus q, which is basically revision from grade 10, and we're going to look at the effect of a and q and the characteristics of that function. Number 2, we're going to look at functions of the form y equals to cos k times theta, and we're going to look at the effect of k and the characteristics of those functions. Number 3, we're going to look at functions of the form y equals to cos of theta plus p, and we're going to look at the effect of p and the characteristics of that function. And lastly, number 4, we're going to look at how to sketch different types of cosine graphs and how to solve questions and problems related to cosine functions. We have a lot to cover, so let's start. First, let's look at grade 10 revision functions of the form y equals to a cos theta plus q. But before we look at the general form, let's look at a specific particular one, which is y equals to cos of theta. Notice that with this one, your a is equals to 1 and your q is equals to 0, meaning that the amplitude is 1 and the graph has not been shifted in any direction. This graph starts with a maximum turning point at 0 degrees and 1. Here's your first x-intercept at 90 degrees 1. The first minimum turning point is at 180 degrees negative 1, and then you have the second x-intercept at 270 degrees 0, and the second maximum turning point at 360 degrees and 1. Your amplitude is 1 because the distance from your point of rest, in this case the x-axis, to either your maximum turning point or your minimum turning point, starting from x-axis exactly same, is 1. And your x-intercepts are at 90 degrees and 270 degrees. Your y-intercept is at 0 degrees and 1. And the domain is simply 0 to 360 degrees. Remember, the domain is a list of all those x values, in this case, theta values that are valid and are defined in the function. And the range is a list of all possible y values that are applicable for this function. Notice that the minimum y value is negative 1 and the maximum is 1. So the range goes from the minimum point to the maximum point of y values, and that's between negative 1 and 1. Now let's look at the more general form and how the q affects it. Now for y equals to a cos theta plus q, q basically affects your shift up and down. So if q is positive, your shift is going to be up. If q is negative, your shift is going to be down. For example, for y equals to cos of theta plus 3, all we did was take this graph of y equals to cos theta and shift it 3 units up. So for each milestone, each point, we just basically took that 1 to 3 units up. Same thing with the resting point. We took the x-axis and shifted it 3 units up, 1 to 3, and that makes it easy for us now to figure out what the other points are. First of all, look at the first x-intercept. That was at 90 degrees. You still have a similar point. It's no longer an x-intercept because it's not cutting the x-axis, but it's still cutting the point of rest or the axis of rest for this particular one that has been shifted at the same point, 90 degrees. But at this point here, the intersection between the point of rest and your 90 degrees is 90 degrees and 3, which is your q. Same story if your y equals to cos of theta minus 1, that means your graph was shifted 1 unit down. Now let's look at the effect of A. The effect of A on all types of graphs, whether they are algebraic or trigonometric, is basically the shape. If your A is positive, you've got your graph normally like this. It starts from the first turning point, that is a maximum turning point, goes to your x-intercept and then minimum turning point, and then x-intercept again and then maximum turning point. When your A is negative, however, what happens is that your graph is flipped upside down. So instead of your graph starting with a maximum turning point like you would have with the red one, which is y equals to cos of theta, the y equals to minus cos of theta starts at a minimum turning point of 0 degrees and -1. So you're flipping this whole graph upside down. You flip the red one upside down, and now the turning points have exchanged. The maximum turning point now has changed into a minimum turning point, and the minimum turning point has changed into a maximum turning point, and so on and so forth. But notice that your x-intercepts remain exactly where they were. Now, what happens when your A is multiplied by a factor? For example, when your A is equals to 2, y equals to 2 cos theta, you still have the same shape, starting with a maximum turning point, going to an x-intercept at 90 degrees, with a minimum turning point, right, at 180 degrees. But what happens is that your y values change. So your amplitude, which is A, is multiplied by the same factor. So your amplitude is now 2 instead of 1. Also, remember something. Your amplitude is the absolute value of A, meaning that it basically is just a measure of the length. We're not really concerned about the direction. The direction just determines what the graph is going to look like in terms of shape. It does not determine the length of the amplitude. So if your A is -3, your amplitude will simply be equals to the absolute value of -3, which is equals to +3, because the absolute value, these signs make whatever is inside positive, whether it is negative or positive. Makes everything. So we're dealing with length, not necessarily direction. Yes, the negative tells us that your graph is flipped upside down, like y equals to -3 cos theta. You're starting with a minimum turning point, right, instead of a maximum turning point, and it starts at -3 because your amplitude has been blown up to 3, no longer 1. X-intercepts are still exactly the same thing. Your maximum turning point now is where your minimum turning point should be. It's at 180 degrees, but the y coordinate of that point is 3 because that also matches with your amplitude. Now let's look at functions of the form y equals to cos of k times theta. What is the effect of k? Basically, the effect of k is on the period. Once you've got your theta multiplied by a variable, that means that variable affects the period. So the period now becomes 360 degrees divided by the absolute value of k. Because the absolute value makes sure that it does not matter whether your k is positive or negative, because what it does, the k may maybe affect the shape, but it will not necessarily affect the period. The sign of k will not affect the period. It will affect the shape. It is the k that affects the period. So how do we calculate that? Now let's go back to the standard one, y equals to cos of theta, which is the grid graph. Remember, it starts at a maximum turning point at 0, 1. First x-intercept is at 90 degrees. Then your minimum turning point at 180, and so on and so forth. And the total period is 360 degrees, because that's how much it takes for you to have a complete cycle. And the complete cycle of a cos graph has got the first turning point, maximum, and then in the middle somewhere you will have a minimum turning point, and then the last bit will be another maximum turning point. That's a full complete cycle. Now what happens when your k is equals to 2, for example? How does that affect the period? First of all, let's just calculate that. Remember, period is equals to 360 degrees divided by the absolute value of k. Our k in this case is 2, because that's what your theta is multiplied by. So we divide that by 2. Remember, the absolute value makes sure that whether your k is negative or positive, it will be positive. So 360 divided by 2, that is 180 degrees, meaning that you will need only 180 degrees to complete this cycle. Also, alternatively, it also means that you will fit 2 full complete graphs in a space of 360 degrees. Now let's look at the blue graph, which is y equals to cos of 2 theta. Let's see. The period is 180 degrees, so here is the first maximum turning point, the first x-intercept. Notice that it is only half of the original. And then you've got your minimum turning point there at 90 degrees, and then at this point you've got your x-intercept again, and then your maximum turning point, the last one, is at 180 degrees. Notice that you've got two full complete cycles in a span of 360 degrees, which is what the K in this case is telling us. So, but notice that also you have your milestones also divided by 2. So instead of the first x-intercept being at 90 degrees, it's at 45 degrees, meaning that we've divided that also by 2. So not only is your period divided by 2, but all the associated milestones in that function are also divided by the same factor, which is the absolute value of K. So meaning that to figure out what a milestone is, right? A milestone is basically from the first maximum turning point to the first x-intercept. And in a normal y equals to cos of theta graph, that only takes 90 degrees. Will that help us figure out what the period is? Let's try. 90 degrees, let's multiply that milestone by 4. That gives us 360 degrees. So here is another method of figuring out how to draw the graph. You just figure out what the milestone is, and then basically just add that to each and every one to figure out what the next milestone is going to be and why. Now for y equals to cos of a half theta, what is the period going to be like? So period, let's figure out what the period is going to be. That's 360 degrees divided by the absolute value of a half, which is equals to 360 degrees multiplied by, flip this upside down, 2 over 1. And that gives us 720 degrees, meaning that it will take 720 degrees to complete a full cycle. Also, it means you can only fit half of a complete cycle in a space of 360 degrees. Let's see what the green graph looks like. The green graph looks exactly the way the data says it should look. Notice that this is the maximum turning point, that's the beginning. And then your first x-intercept is at 180 degrees, which is 2 times 90 degrees. So yes, your milestone now your milestones have been multiplied. How? We just went the milestone, which is 90 degrees, divided by your absolute value of K. Your milestone 90 degrees divided by the absolute value of K, which is equals to 90 degrees divided by, in this case, half, which is equals to 90 degrees multiplied by 2 over 1, which is 180 degrees. So that is how now you know what your milestones are going to be like. So all you do now is you count every 180 degrees, you must have a milestone. And that's how you duplicate that graph that has a period that varies depending on what your K is. Now also notice something. For the cos of theta, cos of minus theta, very important, cos of minus theta is also equals to cos of theta. How come? Let's look at the cos diagram. With the cos diagram, you start your 0 at this point, and then that is 90 degrees. That is the anti-clockwise direction is your positive degree direction. But as soon as you go from 0 and you go back, and that's how sometimes you can access the fourth quadrant, which is where your cos is positive. The cos diagram basically tells you what function, trigonometric function, is positive there. Where? all of them are positive in the first one. In the second one, only sine and its reciprocal are positive. And the third one, only tangent and its reciprocal. And on the fourth quadrant, it's cos and its reciprocal that are positive. So meaning that it does not matter whether your angle is positive or negative, as long as it lands on the fourth quadrant. So your cos of minus theta is the same as the cos of positive theta. And that's how that happens. Now let's look at an example to illustrate all the knowledge that we've. But before we do that, let's look at the characteristics. The characteristics of this, the domain is basically all elements of real numbers. All right. The range, because your amplitude is 1, will be between -1 and 1. If your amplitude is just a general A, then the range will be -1 to 1. The period is basically 360 degrees divided by the absolute value of k, because it depends on what the value of k. In other words, it depends on what your theta is multiplied by in the equation. The x and y intercepts follow the same pattern with algebraic expressions, algebraic functions. Your y-intercept, to find the y-intercept, you make theta 0 in this case, or x 0 in general, and then solve. To find your x-intercepts, you make y 0 and then solve. Now let's look at an example to help illustrate what we've just learned. Sketch the following functions for theta is between -180 to 180. For each graph, determine the period, amplitude, domain, and range, x and y intercepts, maximum and minimum turning points. What we're going to do here is figure out what the periods are, because the domain and the range are exactly the same, because the amplitudes are the same. Why? The domain is between 180 and for all of the functions, because that is the restriction that we were given. So the domain for all of the functions, the domain is what we are given, -180 degrees to 180 degrees. And the range, because all of them have got 1 as A, they've got the same range, which is -1 to 1. Same as the amplitude, they also have the same amplitude, which is 1. All of them, the same amplitude. Maximum and minimum turning points, we're going to figure that out as soon as we plot the graphs. For the x and y intercept, they're also going to be figured out easily. But let's look at what the periods are going to be. The periods will be different because you've got different k's at play here. So let's look at the period for the first one. Remember the equation for the period equals to 360 degrees divided by the absolute value of k. Our k in the first example, f of theta, is 2. So to find the period, we simply divide that by 2. And that gives us 180 degrees. So we have 180 degrees as the period for the first one. For the second one, let's calculate for the second one. It's 360 divided by the absolute value of 1/3. That is our k. Our k is 1/3. 1/3. 1/3, meaning that now we multiply things. So that's 360 multiplied by 10, flip it upside down, 3/1. That is equals to, take out a calculator, 360 degrees multiplied by 3, that is equals to 1080. 1080 is your period here. 1080 also means only a third of the graph can be drawn in a span of 360 degrees. Now this one, cos of -2 theta, like we said, is going to be cos of 2 theta because of that special cos angle calculations. Okay, so cos of is going to be, so the period is going to be exactly the same as that of the function of theta. So that is going to be 180 degrees. Let me remove this. So it's going to be 180 degrees as well. And then the period for the last one, k of theta, your k is equals to 3 over 4. I mean, if absolutely, yeah, your k is 3 over 4. So you divide all of that by 3 over 4. So that becomes 3 over 4, absolute value of 3 over 4, which then gives us this 360 multiplied by, flip that upside down, 4 over 3. And that gives us, take out a calculator, 360 multiplied by 4 over 3. That is equals to 480 degrees. So we have 480 degrees as our period over here. 480 degrees. Why is this important? This helps us figure out what the milestones are. We know what so the milestones, now I've drawn a table so that we can find different milestones for each and every one of that graph. Okay, to find the milestone of f of theta, we must divide 360 by 2, or each and every one of the milestones by 2. So let's divide them. 0 divided by 2, that is 0. That is 0 degrees. 90 divided by 2, that's 45 degrees. So it will have an x-intercept of 45 degrees. 180 degrees divided by 2, that's 90 degrees. So that we will have a minimum turning point at 90 degrees. 270 divided by 2, that gives us, okay, here is another method. So basically all we're doing is adding 45. So 90 plus 45, that's the milestone we'll figure out. 90 plus 45, that is 135. So now that we figure out what the milestones are, it should be easy. Next one, 135 plus 45, that is equals to 180 degrees. Now for the blue graph, at 0, 0 divided by 1 over 3, that is 0. Okay, next one, 0 divided by, let's figure out what the milestone is. Next one, 90 degrees divided by, okay, 90 degrees divided by 1 over 3, that is equals to 270, which is outside of the range here. This is outside of the range, so what we will do instead is find out what your y is at 180, because we're not going to have a point where we will have that x-intercept. The first x-intercept we will have in this graph is at 270 degrees, and that is outside of the range. So what we need to do is figure out what g of 180 degrees is, because that's the last point on the restrictions. All right, next, the green graph is exactly the same as the red graph, because that is h, that is equals to cos of minus 2 theta, so it will have exactly the same milestones as the red graph. So I'm not going to waste time calculating. Now for this one, we divide 0 by 3 over 4, that is 0. And the next one we divide 90 degrees by 3 over 4, so common fraction button 90. Downward arrow, another common fraction button, and that is 3. Downward arrow 4, and then that is equals to, that gives us 120 degrees. So meaning that every 120 degrees we have a milestone. So the next one will be 240, right? But 240 is outside of the range here. So here at 180 degrees, we'll just figure out what the k of 180 degrees is. And let's do that. Let's start with this one. Let's find out what g of 180 degrees is. G of 180 degrees is equals to the cos of, okay, so that will be the cos of 180 degrees divided by 3. And that is equals to Okay, take out a calculator. Cos, common fraction button, 180 at the top, downward arrow 3, right arrow, close bracket, that is equals to 1 over 2. So at that point, it will be half. Now let's find out what K of 180 is, because this one also has those limitations. K of 180 degrees, that is equals to the cos of 3 times 180 divided by 4, and that is equals to cos of common fraction button 3 times 180 at the top, downward arrow 4, right arrow close bracket equals to, that gives me negative square root of 2 over 2, which when I press the S to D button gives me negative 0.707. Right, now let's try and plot the graphs. Let's start with the G of theta. So the milestone there is 45 degrees. Okay, let's start with the red one. So at the beginning, you've got a maximum turning point at 0, 1. And then the milestone is 45 degrees, meaning that your first x-intercept will be at 45 degrees. So that is 45 degrees. Next 45 degrees, that will give me a my minimum turning point. So minimum turning point there. Another 45 degrees will be somewhere here in the middle. That's another x-intercept, and then the last one will be at 180 degrees, and that is the maximum turning point. What we do now is we duplicate, we mirror the point on the other side. So this one, which is 45 degrees, should match with this one at negative 45 degrees. We must have a x-intercept. Minimum turning point, again, at negative 90 degrees. And then over here, between these two, 120 and negative 120 and negative 150, we must have an x-intercept. And then the last one is a maximum turning point at negative 180 degrees. So all I've done basically is duplicate and mirror the points. Now we join the points together. That's how you join the points. Easy peasy. Once you get the points located in the right places. Okay, let's fix the last one. That is the graph of f of theta equals to cos of 2 theta. Now let's plot the graph of g of theta equals to cos of theta over 3. Here, the first point, the maximum turning point is at 0, 1. Okay, and we do not have an x-intercept in the range, within the range. So what we do is we calculated what our y is going to be at this point of 180 degrees, and we found that to be half. G of 180 degrees is half. So we plot where half is, that will be there. Okay, this is, okay, let's fix that. There is my half. So what we do is we duplicate, we mirror the same, sorry, no, our half is here. So what we do is we must mirror, okay, this is 0, that is 1, so half is in the middle. All right, so we mirror this, we join the line, use the guide, there it is, there is where we're supposed to plot another point on the left hand side. And now we join the points together. Okay, there we go. All right. So there we go. Now let's plot this graph h of theta equals to cos of minus 2 theta. Remember, this is equals to cos of 2 theta, which is f of theta. So exactly the same milestones and points that of theta reached, we must go the same route. So the first one is over here at the maximum turning point. The next one is there. Next one, next one, next one there. And then we mirror those on the left-hand side. So that means the graph of h of theta is going to go exactly, it's going to sit on top of the graph of f of theta. And so we basically just join, follow the direction, just follow the direction of the red graph. Just let me fix that. All right. And that is the green graph. Now the last one, k of theta equals to cos of 3 theta over 4. The milestone over here is 120 degrees. Here is the milestone. It's 120 degrees for every 120 degrees. But we've noticed that that is the only one we will have. The next one, we calculated f of k of 108 degrees, and we see that it's negative 0.07. So now let's plot the milestone. That is the black graph. It starts at the maximum turning point, and then the milestone is at 120 degrees. That's the first x-intercept. Let's duplicate that same point on the left-hand side. There we go. Now, f of k of 180 degrees, the y-intercept at theta equals to 180 degrees is negative 0.70. This point over here is 0.5, and this point over here is 3/4. 3 over 4, 3 over 4, when you use s to the button, is 0.75. We're looking for 0.707, so that will be somewhere there, just below. Right. Same on the other side, we find the same point and we duplicate it. Right. And then we go, okay, let's join them together. Okay, we join this two first. Oh, no, we should be using a purple one, not a black one. We're using a purple color. All right. Let me fix that. Okay. And that is how you draw the graphs. Now let's look at what the graph calculator calculated for us to check if we've got everything right. And there is the graph. The purple one goes exactly the same, the red one and the blue one. Remember, the green one also includes the red one because they lie on top of each other, and that's how the graphs go. Now let's look at functions of the form y equals to cos of theta plus p and the effect of p. The effect of p basically is shifting to the left or to the right. Just like with any algebraic function, p represents shift to the left or right, or whatever variable they put as a plus of the theta inside the angle. So p, when p is positive, right? When p is positive, we need to remember this. When p is positive, positive p means it's shifted to the left. And then negative p means it's shifted to the right. Remember that they kind of like go against logic. They just go the opposite direction of what your mind automatically thinks when you think about minus and plus. So here is y equals to cos of theta. It starts right at the origin with a maximum turning point at 0 degrees 1. That is not shifted in any direction. It's not shifted top to bottom, it's not shifted to the left or right. So P will show us how it is shifted either to the left or to the right. Now let's look at y equals to cos of theta minus 90. This graph is a shifted graph of cos of theta 90 degrees to the right, because you've got a minus there. Minus means to the right, so we go. So from the red graph, which is the reference, we count 90 degrees to the right. This one is made into pieces, bits and pieces of intervals of 30 degrees. So that's 30, 60, 90, and there is your first peak. Now, to figure out the rest of the milestones, in other words, your x-intercepts, your minimum and maximum turning points, what you do is you just count 90 degrees. Why? Because the period is still 360 degrees. 360 degrees, it does not change. So you go 1, 2, 3. And when the period is 360 degrees, 360 degrees divided by 4 is a milestone. So you count 90 degrees to find the second milestone. So that will be your x-intercept, 90 degrees, 1, 2, 3, minimum turning point, 1, 2, 3, x-intercept, 1, 2, 3, maximum turning point, and so on and so forth. Same thing to the right, to the left. Let's look at the green graph. Y equals to cos of theta plus 90 degrees. That means it is shifted 90 degrees to what direction? The left. Plus tells us it's shifted to the left. So we go back to the focus graph, the one that's not shifted, y equals to cos theta, and we count 90 degrees to the left to figure out where the shifted graph of the green graph lies. So we'll go 1, 2, 3, that's negative 90 degrees. 90 degrees to the left, and that's the first peak. To find the rest of the milestones, 1, 2, 3, 90, x-intercept, 1, 2, 3, minimum turning point. 1, 2, 3, x-intercept, and so on and so forth. Now for the graph of y equals to cos of theta plus 180 degrees. Direction of shift is naked to the left, and the magnitude of shift is 180 degrees. So this one was shifted 180 degrees to the left, and then obviously you duplicate after that. So we start from the focus one, y equals to cos theta, the peak, and then we go 1, 2, 3, that's negative, that's 90 degrees to the left, 1, 2, 3, another 90 degrees, and that gives us 180 degrees, and that's where you land. So to find the rest of the milestones, you must count 90 degrees, 1, 2, 3, that's your x-intercept, 1, 2, 3, minimum turning point, 1, 2, 3, x-intercept, 1, 2, 3, maximum turning point, and so on and so forth. That's basically how you duplicate a function that is shifted without having to calculate each and every milestone by hand. You just use the knowledge that you have of how the shift happens, and then you plot the graphs of the shifted functions accordingly. Now let's look at an example. Example says for each graph of the form f of theta equals to cos of k times theta, determine the value of k. Now the k tells you that the period is determined by the k, by the factor that theta is multiplied by. So what you do is you now try and figure out where the graph starts and where it ends. Try and figure out how many degrees it takes for a full complete cycle. Let's start with this one. This one looks like a cosine graph which says a minimum, a maximum at 0 degrees. So let's see. That is one milestone, another milestone, another milestone. Okay, this is where the graph completes its cycle. We're not sure what this point is, so this is one complete full cycle, and it is not 360 degrees, so it's something less than 360 degrees. But exactly how much are we dealing with here? So let's see, this is one milestone, milestone number 1, milestone number 2. 3 milestones span 180 degrees. So let's figure out what a single milestone will span. So 3 milestones in this case, 180 degrees is 3 milestones. So if we divide that by 3, that gives us 60 degrees. So that means one milestone is 60 degrees, meaning that that point there is 60 degrees. And obviously this point is 120 degrees because that's 60 times 20. And then this one is correctly 180 degrees. Now that we know what the milestone is, we figure out what the milestone is. Okay, the milestone here is equals to 60 degrees. So the period will be easy. Just multiply the milestone by 4. So period equals to milestone by 4. Okay, so we'll figure that out. So milestone here. Okay, so this is where we went. 180 degrees. 180 degrees gives you 3 milestones. So that is equals to 60 degrees. That is a milestone. Okay, so the period will be equals to 60 degrees multiplied by 4. And that is equals to 60 times 4. That is equals to 240 degrees. That's our period. But notice something also. The period equals to 360 degrees divided by the absolute value of k. Meaning that therefore the absolute value of k is equal to 360 degrees divided by the period. And we know the period in this case, our period is, in this case, our period is 240 degrees. 240 degrees. Now we go, okay, let's see if we can simplify this. All right, 60 degrees goes, okay, into 244 times. Okay, 60 degrees goes 4 times. 4 times here. And 60 degrees, 360 degrees divided, okay, by 60. It goes 6 times here into 360 degrees. But let's see something. 2 goes into 4 twice and into 6 3 times. So your k here is equal to, so therefore our k is equals to 3 over 2. Now let's look at number B. Number B, okay, we've got 1 milestone. This one starts at the maximum turning point here and reaches its first milestone, the x-intercept, at 135 degrees. There is the 135 degrees. Let me maximize that so you can see. So that is 135 degrees, meaning that 1 milestone is equal to 135 degrees. So milestone here, milestone equals to 135. Okay. That makes it easy for us to find the period. We already have the milestone equals to 135 degrees. Therefore, period equals to that multiplied by 4. 135 multiplied by 4, which is equals to, let's see what it is. 135 multiplied by 4, the period is 540 degrees. Let me fix that. 540 degrees. All right, so now to find k, okay, we know that the absolute value of k is equals to 360 degrees divided by the period. And we know that the period here is equals to 360 divided by 540. Okay, let's see. 180 goes into 543 times. 180 goes into 543 times. And it goes into 362 times. So your k is equals to k equals to 2 over 3. That is how you answer that question. Now let's look at the next example, which is example 3. Now we're looking at sketching the cosine graph. In general, sketch the following functions on the same set of axes. For your domain, your theta is between 360 and negative 360. The first one is your normal sine cos theta. And the second one is cos of theta plus 30 degrees, which is shifted. This one is a shifted graph. Okay, this one is a shifted graph. Shifted plus means to the left, so it's shifted 30 degrees left. All right. So the period is going to be the same. The period is going to be 360 degrees because your case for each and every one of them is 1. Period equals to 360 degrees for both of them. Amplitude is 1 for both of them because your A is 1. The domain is the same, negative 360 to 360 degrees, and the range is also the same. Domain is negative 360 to 360, and then the range is between negative 1 and 1. The x and y intercepts, the maximum and minimum turning points will be determined by the graph after we shift. Okay, now let's start with the first one. The normal, the basic standard one, y equals to cos of theta. The y equals to cos of theta. At 0 degrees, it reaches a peak, that's a maximum turning point at 1. And then at 90 degrees, that's the first turning point. This one is divided into division sections of 30 degrees, 30, 60, 90. That is the first one, 90 degrees. Then 30, 90 degrees, okay, 3 ones, 1, 2, 3, that's our minimum turning point, there. 1, 2, 3, that should be our intercept, x-intercept, and then 1, 2, 3, that is the last bit. There is the second maximum turning point. And what we do is we just duplicate and mirror the same on the left hand side. So 1, 2, 3. Then 1, 2, 3, we have a minimum turning point. 1, 2, 3, we have an x-intercept. 1, 2, 3, we have a maximum turning point, and that's the last bit. And then we join them together. Let's join the points together. And that is how you join them together. Now let's draw the graph of y equals to cos of theta plus 30 degrees. This one is shifted 30 degrees to the left. So we go to the first one. Okay, let me fix this bit. Okay, let me fix that. All right. So what we do is from the basic one, the standard one, the maximum turning point, we count 30 degrees to the left. And there it should end. There is where our maximum turning point should land. So the first maximum turning point is there. And now we just continue to count in 90 degrees and then get the milestone. So 1, 2, 3, that's the first milestone, it will be A. So there is the first milestone, and then we count again. 1, 2, 3, that's another milestone. 1, 2, 3, another milestone. Then the last milestone, let's see. 1, 1, 2. The third one is outside of range. So we go 1, 2, and then we calculate. We find out what the cost of the function is there at negative 360 degrees. So we calculate, here is what we calculate. We go cos of negative 360 degrees plus 30 degrees. Okay, let's find out what that is. Take out a calculator. So we go cos of negative 360 plus 30 equals 2. That gives us square root of 3 over 2. That is equals to square root of 3 over 2. And when we press the S to D button, it gives us 0.8666, which is 0.87. So that's the point that we must figure out here, 0.877. Okay, this is 0.5, that is 1. That is 0.75. So 0.86 should be somewhere up there. There we go. All right, so let's duplicate the points. So 1, 2, 1, 2, 3. That's another milestone there. Milestone there. 1, 2, 3. Another milestone. 1, 2, 3. Another milestone. 1, 2, 3. Another milestone. There is the milestone. And then on 360, the next milestone is outside of the range. So what we do is we now calculate what the y value is at 360 degrees. So we go, same story. Now we just remove the minus and make it positive. Let's see what we get. So let's see what we get. Cos of 360 cos of 360 plus 30, those bracket, that is equals to square root of, it goes to square root of 3 over 2 as well. So that's 0.87 as well. So the 0.87, all right, it will be exactly on the same point as the same level as the other one. Okay, let's just go a bit further down. All right, so now we join the points. Okay, let's remove this before we join the points. Okay, let's join the points now. Okay. Okay. There is the point. Okay, here is joining the points here. Then the points are joined here. And that's how you draw that a shifted graph. Now let's look at what the graph calculator. So that is exactly the same thing we got. All right. That's why negative 360. So let's see. The blue one lies just under the red one. Okay, there we go. All right, now let's continue. Example number 4, sketch the graph of f of theta equals to cos of 180 degrees minus 3 theta 4. Your domain is between 0 and 360 degrees. So what we do is, first of all, we figure out what the period is going to be like, but by making sure that we factorize. Okay, notice that your theta is multiplied by 3 over here. So meaning that your period is going to be not going to be 180 degrees, 360 degrees. In fact, it's going to be 360 degrees divided by 3. 360 divided by 3. So the period is going to be 120. But let's factorize. So what you do is you factorize. You go, therefore f of theta equals to, okay, cos of, okay, 3 in bracket. Okay, let's take out a common factor of 3. We're left with 60 minus 3. Degrees minus theta, okay. But we must make sure that we start with the angle, not the, we start with theta, not the angle. So what we do is we switch them around. How do we switch them around? What we do is we play a trick. And then that trick is we take out a minus sign. So we can now switch them without any problem. And I'll show you why that is applicable, why that is. So that becomes theta minus 60 degrees. Why is that minus sign helping? That's because minus 3 times theta minus 60, that is equals to minus 3 theta plus 3 times negative 3 times negative 60, that's positive 180 degrees, which basically takes us to what we started with at the beginning. That's 180 degrees minus theta, minus 3 theta there. That's why that's how the minus helps. So if you want to change the order of things around, you just put a minus in front. If you have a minus, just put a minus in front of everything, and then. But remember that cos of negative theta is equals to cos of theta. All right. So this one is also cos of equals to cos of 3 times theta minus 60. So now let's figure out where this one starts and where the milestones are. Okay, let's look at what happens if we were to look at the milestone at 0 degrees. For 0 degrees, what does this one, where does this one start? Okay, let's do 3 theta minus 60 degrees. Mesh that with 0 degrees. Let's see what the milestone gives us. So that's 3 theta minus, okay, so divide both sides by 3, you're left with 3 with theta minus 60 on the left hand side, theta minus 60 on the left hand side, and 0 degrees divided by 3, that is 0 degrees. Therefore, theta equals to, take the 60 to the right hand side, minus 60 to the right hand side, it becomes 60 degrees. This is where we start. All right. Now the question is, what is the milestone? Okay. What is the period? Let's figure out what the period is, and then we divide that by 4, so we figure out what the milestone is. Okay. The period first, period equals to 360 degrees divided by k is 3, so absolute value of 3, and that gives us 360 divided by 3. 360 divided by 3. That is equals to 120. That's equals to 120. Okay, that is our period. Milestone is that divided by 4. Milestone is simply equals to the period 120 divided by 4. And that is equals to 120 divided by 4 is equals to 30 degrees. So this is where we start. We start at our maximum turning point. The first maximum turning point will be at 60 degrees and 1, 60 degrees and 1. And then the milestones will now be increased by 30. So the first x-intercept will be at 60 degrees plus 30 which is the milestone we reach, which is close to 90 degrees, and so on and so forth. To find the rest, we just add 30 degrees. So let's first plot the graph of the normal function, which is cos of theta. Y equals to cos of theta. So at 0 degrees, it's a maximum at 1. Then 90 degrees, that's the first x-intercept. At 90 degrees. Minimum turning point is at 180, negative 1. Then the next x-intercept is at 270. That's not 270. And then the last maximum turning point is at 360 degrees. Well, that's the normal graph of a cosine function. Now let's join the points. Let's join the points. All right, let's join the points. That's the graph. Now let's draw the graph of y equals to cos of 180 degrees minus 30. Remember the first point where the maximum turning point is at 60 degrees and 1. 60 degrees, that's where we start. 60 degrees, that's where we will have our maximum turning point. So let's plot that. There is the maximum turning point, and then the milestones are reached every 30 degrees. That is the milestone every 30 degrees. So every 30 degrees. So that is 30 degrees, 60 to 90, that's 30 degrees. So that is where our first x-intercept is going to be for the blue graph. Then another 30 gives us the minimum turning point. That's at 120. Another 30 at 150. That gives us another x-intercept. Another 30 at 180, maximum turning point. X-intercept, minimum turning point. X-intercept, maximum turning point. X-intercept, minimum turning point at 360 degrees. All right, so these are 30 degrees, okay. Another milestone is there at 30 degrees. So at 30 degrees, we've got an x-intercept, okay. And then at 0 degrees, we've got another one milestone. That's the minimum turning point. Now let's join all these graphs. The points, I mean. All right, so this is where we started. All right. Okay. That's how we join the points. Basically, in a space of 360 degrees, we must have 3 complete cycles according to our K. Let's check. This is 1 cycle, 2 cycles, 3 cycles. Yes, it matches. Now let's see what the graph calculator calculated. This is exactly what we found. 1, 2, 3 complete cycles. Now for example number 5, given the graph of y equals to a cos k theta plus p, determine the values of a, k, p, and the minimum turning point. So we need to find the minimum turning point. That's what we need to find. Okay, let's give it a point there. There is the minimum turning point. That's what we need to find. So we need to first figure out what our K, A, K, and P are, and then use the points we have here to figure that out and to find the minimum turning point. Okay, first of all, let's figure out what the period is. We're going from negative 45 degrees all the way to, okay, this is a complete cycle. Even though it looks more like a sine graph, it goes all the way from negative 45 degrees to 315. Let's see. So 315 degrees plus 45, 315 plus 45. That gives us a complete cycle, and that is 360 degrees. So 315 degrees plus 45 degrees equals to 360 degrees. And that gives us a clue as to what the period is. Therefore, the period is equals to 360 degrees. Okay, let's the period equals to 360 degrees. Why is this important? This is important because when the period is 360 degrees, that means our K is 1. Therefore, K is 1. How did I figure that out? Remember, the period is equals to 360 degrees divided by the absolute value of K. Therefore, the absolute value of K equals to 360 degrees divided by the period. Now, we know that the period is 360 degrees. So that means our K is equals to 1. 360 divided by 360 is 1. So K is equals to 1. And now let's figure out what the equation is. Therefore, the equation is y equals to A cos of theta plus P. K equals to 1. All right. Now notice that your maximum turning point is at 45 degrees and 2. Maximum turning point, max TP, at 45 degrees and 2. Meaning that therefore your A is equals to 2. Therefore, y equals to 2 cos of theta plus P. Also, notice that instead of your peak, the maximum turning point starting at 0 degrees and 1 and 2, it instead starts at 45 degrees, meaning that your graph was shifted 45 degrees to the right. Okay. Max TP, the maximum turning point at 45 degrees and 2, meaning that therefore graph shifted 45 degrees right, meaning therefore your P equals to negative 45 degrees, meaning that therefore your y equals to 2 cos of theta minus 45 degrees. That's your y. Now, in order to figure out what the minimum turning point is, okay, obviously the minimum turning point will be at negative 2, all right? The y-intercept, the y-coordinate of the turning point will be at negative 2. So what we do is you substitute that, okay, minimum turning point, turning point at y equals to negative 2. So let's substitute that. Therefore, negative 2 is equal to negative 2 is equals to 2 cos of theta minus 45 degrees. Now divide both sides by 2, you get negative 1 equals to cos of theta minus 45 degrees. Okay, therefore, to find your angle, therefore the cos to the minus 1 of negative 1 equals to the angle in this case, which is theta minus 45. Theta minus 45 degrees. Now, cos of to the negative 1 minus 1. Okay, so you go shift cos negative 1, close bracket, and that is equals to 180 degrees. So the left hand side is 180 degrees equals to theta minus 45 degrees. Therefore, take everything that is not theta to the left hand side, so you've got 180 degrees plus 45 degrees equals to theta. 180 plus 45, that is equals to 225. So therefore, that means the minimum turning point is the point negative, 225 degrees and negative 2. Does it match? Let's check. Of course it does match. 225 is the correct answer here because it does match. So that is 225 degrees and negative 2. Now let's double check. We know that from the maximum turning point, the first maximum turning point, to the minimum turning point, it is a span of 180 degrees for a period of 360 degrees. So we'll go 45 plus 180, 45 degrees plus 180. That will give us 225. Yes, it matches. All right, now the last one. For the last example, two girls are given the following graph. Here is the graph. It starts at a minimum turning point of at negative 1, 0 degrees, negative 1. The first milestone is at 90 degrees. So you can tell you obviously dealing with a cosine graph over here. So the first milestone is 90 degrees and the period is 360 degrees. You've got a maximum turning point at 180 degrees and your x-intercepts at 90 and 270 degrees. Now, Audrey decides that the equation for the graph is a cosine function of the form y equals to a cos theta. Determine the value of a. That should be easy. Okay. For Audrey's case, number A, Audrey says if y equals to a cos theta, right? Okay, this point 0 degrees and negative 1 lies on y. All right, that's the point. It's at the beginning. Right at the beginning, there is the point. 0 degrees and negative 1. That's part of y. Therefore, we substitute. Okay, let's substitute. Let's substitute the point. So negative 1 is equals to a cos of the angle is 0 degrees. Therefore, negative 1 equals to a cos of 0 degrees. Take out a calculator. Cos of 0 degrees, that is equals to 1. So that is a times 1. Therefore, negative 1 equals to a. So meaning therefore, equation is y equals to negative cos of theta. And then the next question goes, for the value of a is -1. Megan thinks that the equation of the graph is a cosine function of the form y equals to cos of theta plus p. Determine the value of p. If y is equals to b, y equals to a cos of theta plus p, we're supposed to determine the value of p. All right, same thing, the point. On y. Okay, let's substitute that point. Therefore, -1 equals to a cos of 0 degrees plus p, meaning that therefore -a equals to cos of p. All right. Therefore, cos to the -1 to find the angle, cos to the -1 of that is equals to p. P equals to that. Okay, therefore, what is cos to the -1 of -1? Second function shift, cos -1, close bracket, that is equals to 180 degrees. Equals to p. That is p, meaning that therefore y equals to sorry, is that a? No, sorry, there is no a here. Okay, sorry about that. It is just y equals to cos of theta. All right, sorry about that. All right, so therefore y equals to cos of 180 degrees plus p. I mean theta plus 180, sorry. Theta plus 180 degrees. Therefore, okay. Now number C asks the question. So we've got our P and we've got the new. What can they conclude? Here is the conclusion that can be made. Here is the conclusion. The conclusion that can be made is that the cos of theta plus 180 degrees is simply equals to minus cos of theta. That's the conclusion that can be made. We've come to the end of this video. Thank you for watching. See you in the next one. Bye.